All right, moving on in chapter 4, we have started with the polynomials, and now 4.6 is rational functions and models. So not quite exactly polynomials. We need to be able to identify what the rational function is. Horrible. State its domain. Domain is that x or y?
X.
X. Identify asymptotes. You've heard that word before, correct? Interpret what those mean and be able to graph a rational function by using what we know about asymptotes. And transformations from last chapter, and then be able to graph that function by hand. So what is a rational function? Josie, we're going to have you come back to 4.6. You'll probably be able to catch on to this one. Okay. Rational function represented by this format. So we are definitely having a division sign in there, that fraction bar. Okay? What are p of x and q of x? They're polynomials. We spent a bunch of time on polynomials. Now we're actually going to be dividing them and looking at what does this function look like overall as a graph, as a table, and that sort of thing. Okay? It adds this in there. Why? We should not have the denominator equal 0 because we cannot divide by 0. Okay, so we have to look at when does the denominator equal 0 because that's not a possibility. That's not going to be part of our domain. The domain of a rational function includes all real numbers except where the denominator equals 0. Makes sense. The rational function is continuous. You can draw without picking up your pencil at everything where except that denominator equals 0. So that denominator 0 is a big deal for us. So, example 1, we've got 3 equations here. F of x, g of x, and h of x. We need to state, is the function rational? And also then state its domain. What can x be? Sometimes it's easier not to look at what x can be, but it's easier to look at what x can't be. Okay? So, I think I have a spot for each one of these. First of all, is this, question A, a rational function? Is it a polynomial divided by a polynomial? Yes. So we've got a rational function. Now we need to state its domain. What can x be? Well, rather than looking at x can be, what can't it be? Don't I need to look where that is equal to 0 and say we shouldn't have that? Does that ever equal 0?
No.
It doesn't, does it? So do I need to worry about dividing by 0?
No.
So what is my domain? All real numbers. You can write all reals. How do I write that in interval notation? Negative infinity to positive. Because it has a polynomial divided by a polynomial doesn't mean I have a restricted domain, but it very well could be. Okay? Question B. Is question B a rational function? No. It is not. Square root is not a polynomial because that's that fractional exponent. So this is no. Just for the fun of it, what would be the domain? What can't x be? X cannot be 0. We cannot take 1 divided by 0. There's more to it than that, though. What else can't? Yeah. We can't do square root of a negative for having a real graph there. So our domain, we are technically looking where x greater than 0. Normally the square root is greater than or equal to, but because it's underneath the denominator, we cannot have the equal to part. So x greater than 0, or you could do parentheses 0 to infinity, parentheses. Just making sure it was recording. That'd have been bad. We'd have to do it all over again. Question C. Question C. Is that a polynomial?
Yes.
I meant rational function.
Yes.
Yes. Because it is a polynomial. It now says to state its domain. What can't x be?
0. Or when the box.
Not a rational function. So we need to look what x can't be. So I need to look, where does my denominator equal 0? So we are solving a quadratic equation to find that. Why don't you go ahead and give that a shot?
Yes, you are. Trader over here next to me. Trying to fill our brains with false information.
We have strategies for solving a quadratic. We can factor, quadratic formula, vertex form. How many tried to factor this? Is it factorable?
Yes.
Okay. Did anybody just go straight to the quadratic formula or vertex form? That's perfectly fine. That will work all the time, even if it's not. It is factorable. So if it is factorable, what two numbers multiply together to get 2 that add together to get -3? -2 and -1. So x equals 2, x equals 1, or that is 0. So if I plug in 2 here, I have a 0 in the denominator. We can't do that, so it doesn't work. If I plug in 1, a 0 in the denominator, doesn't work. So what is my domain? All real numbers except 1 and 2. That is one way to write that. What if I told you you had to write it in interval notation? -infinity to 1, or 1 to 2, or 2 to infinity.
It is because
Because it could be 1.5.
because it can't be though. It's between.
Okay. Questions? Okay. So something is happening at 1 and 2, and I don't have a graph there. There are a couple different options of what's actually happening when I graph that. One of the options is a vertical asymptote. The line x equals k. By the way, when a graph equation is x equals, is that vertical?
This way.
When it's x equals, is it vertical?
Vertical.
Vertical.
This way. Yeah, that's what it says.
Hence, vertical asymptote. So here's what I remember from previous years. I've asked you to find a vertical asymptote. I want the equation of the line. And sometimes people would get confused about whether it was y equals or x equals. Okay? So keep that in mind. We have a vertical asymptote. If the function goes to infinity or negative infinity as x approaches k from the left to right. So as I go to right, my function's going up unbounded, isn't it? As I go to 2 from the left, it's going down unbounded. So therefore we have a vertical asymptote at x equals, okay? There are such things as horizontal asymptotes. Which way does horizontal go? This way. What is the equation of a horizontal line? Y equals a number. Vertical, x equals. Horizontal, y equals. So that one has a horizontal line, asymptote of y equals 25. Because f of x approaches b. B is the number. Is infinity or negative infinity. As I go and follow my graph and go to positive infinity, what is the height of my function going to? 25. Does it ever reach 25? No. This graph back here, does it have a horizontal asymptote? As I follow my graph to positive infinity, 0. Negative infinity, also 0. So what is the equation of the horizontal asymptote? Y equals 0. So, how do we find them if we don't have a graph? And don't say graph them. Here we have this, p of x over q of x, and it's written in lowest terms. That's going to come into play quite a bit. If it has a common factor, we're going to take that factor out first, and then we'll do this analysis. So to find a vertical asymptote, go ahead and read through that and see if that makes sense to you. How do we find a vertical asymptote? Find a vertical asymptote. We set the denominator equal to 0 and solve. And generally, the answer we get gives us vertical asymptote. Except if the function I start with is not in lowest terms, and I plug in that number, and I also get a 0 in the numerator. That's not going to be an asymptote. It's still not in my domain, but it's not going to be an asymptote. And we will look at what that looks like coming up. So technically on this one here, are there for sure vertical asymptotes at 1 and 2? No. What do we need to do to be sure that there are vertical asymptotes at 1 and 2?
Put them in the top.
Plug it in the numerator and see if we get 0 or not. So 1 cubed minus 2 times 1 squared plus 1. 1 minus 2 plus 1. What do I get? 0. So is there an asymptote at x equals 1 on this function? There is not. How about 2? 2 cubed is 8 minus 8 plus 1 is 1. 1 over 0 at 2. Okay? So this one had a factor of x minus 1 in it. If we had to factor that, we'd have been able to cancel it out, and then I would not have had a 0 in the denominator. Horizontal asymptotes. There are 3 different scenarios that could happen. Read through those 3, and then we will summarize what that means and put it in regular people's terms. Let's summarize. 3 options to determine. We're looking at a rational function, a polynomial divided by a polynomial. First option, the degree of the numerator is less than the degree of the denominator. What does that look like?
X cubed on top and like x to the 4th.
X to the x cubed plus 3x squared minus 5 over 3x to the 4th plus 7x minus 2. Do you agree that is a rational function that has the degree of the numerator less than the degree of the denominator?
Yes.
What does that guarantee me about a horizontal asymptote? Y equals 0 is a horizontal asymptote. Let's think about that. Why does that happen? Is there, yeah, you could certainly memorize these rules and you'll get your answer. But again, I would much rather you understand why. So for horizontal asymptote, we're looking at x goes to infinity, right? In this function, if I plug in 1 million, 10 million, 1 trillion, what's technically bigger here, my numerator or my denominator? Denominator, right? So if I'm taking a smaller number and dividing it every other by a bigger number, I take 1 divided by 10, 1 divided by 100, 1 divided by 1,000. What's my number, my quotient approaching?
0.
0, which is why we have a horizontal asymptote of y equals 0. Follow that? Okay? Option B. So one possible horizontal asymptote, y equals 0. Option B, if the degree of the numerator equals the degree of the denominator, like 3x to the 4th and negative x to the 4th. asymptote. Do I have a horizontal asymptote? Yes. They say then the y equals a over b. Well, what's my a and what's my b?
3, -1.
3, -1. So this rational function will have y equals -3 as a horizontal asymptote. Why is that? Again, as x goes to positive infinity, does this stuff back here really matter? We're so big that this is truly controlling the function, right? But if I plug in a billion, 3 times a billion to the 4th divided by -1 billion to the 4th, don't those cancel? And you get -3 as your answer.
Wait, does it have to be?
I just made that up. Alright, so y equals 0. Y equals the leading coefficient, the ratio of the leading coefficients of your top and your bottom. And then there's another option. What if the degree of the numerator is greater than the degree of the denominator? So like 5x to the 5th and -2x squared. Is there going to be a horizontal asymptote that the line approaches? It's going to increase or decrease unbounded. That is definitely, as the x goes to infinity or negative infinity, the numerator right there is controlling that function. So it is going to go unbounded. Yes? If I go back to this one and ask you horizontal asymptotes, are there any? And if so, what is it? Are there any? No. Degree of the numerator is 3, degree of the denominator is 2, so there is not a horizontal asymptote. What if I went to that function? Horizontal asymptote? Is there one? What's the degree of the numerator? 1. What's the degree of the denominator? 2. So my denominator is bigger. The denominator is growing faster. So what's the horizontal asymptote? Y equals 0.
Yes.
No? It'll take practice. If I take 1 divided by 10, and then 1 divided by 100, and then 1 divided by 1,000, isn't that technically going closer and closer to 0?
Yeah.
Is it always if the denominator is bigger? Yes. Okay. Yes. Yes. Alright, next part. Use the graph of each rational function to determine any vertical or horizontal asymptotes that you see. To abbreviate. List your vertical asymptotes, list your horizontal asymptotes for each set, please. Yes, we have turned the page in our packet.